Now we're going to graph this. This is a little bit trickier reflection, and the reason is because we've got this. We've got the a negative here, but we also have the plus here. And that creates a little bit of a dilemma for us. So what most people will teach you is that you first reflect, then you shift, and then you translate. I'm sorry. First reflect, then stretch, and then translate, meaning move up, down, left, right. So we don't have a stretch on this one, because that would be like a number in front of here or in front of here. We don't have that. But we do have a reflection represented by this negative here. But the tricky part is it's hard to know exactly what we're reflecting unless we reflect. It's hard to know what we reflect unless we factor that out. So my recommendation is to let me do this in green. My recommendation is to first factor out a negative, which means you're factoring it out of both of those terms. So do you see how I've got a negative factored out of it? See, now I can see what my original function was. Now I like to think of my original function as this function in green right here, the square root of x minus 4. What would the square root of x minus 4 be? What would that graph look like? Instead of this, it would be shifted where? What does the minus 4 do?
Up or down 4?
No, it's on the inside. It's with the x, so it's a horizontal shift.
Okay, so
it's right 4.
Right 4.
So my graph is really this. It's really that graph, right? So my graph is this graph right here, but then I'm shifting it. Again, I'll change color so you can see that better. Now I'm flipping that graph. What does the negative do?
Negative is over the y-axis.
It flips it over the y-axis. So it's flipping not over the y-axis, it's flipping over its own vertical axis. So it's actually doing this. Okay, and now I apply the third transformation, which is plus or minus 3 would shift the entire thing down 3. So that's my graph. Now let's make sure it's right. The way to make sure it's right is you plug in the point, and I will plug in this point right here. The point should be 4, comma, negative 3. Let's make sure 4, when I plug in 4, let's make sure I get negative 3.
Okay.
Which you can see that I do. That's another way to do a problem like this, is just take your handle, your main point. So let me show you that way of doing it, because flipping that one, to be honest with you, is a little bit of a confusing concept to me. How I really do this problem is I'll take this equation right here, I'll take what's inside there and I'll set it equal to 0.
Okay.
And then I'll solve that for x. So add x to both sides. X equals 4. X equals 4 is my handle, my main point.
How far are you?
You understand that? So 4, comma, 4 is going to be the point that,
Just come to where I am.
4 is going to be like my main point, my starting point.
Yeah.
And then
Easiest limits.
if I plug in 4 for that, then I'll get, when I plug in 4 to this original equation, I'll get negative 3 as my answer. And so that helps me know where that, like one of the points that is on my graph.
Okay.
And then from there I think to myself, well, which way is it going? Up, down, left, or right? And it's going, because of that negative there, it's going to the left.
Okay.
So that's another way you can think through the problem. But different teachers teach it different ways. I'm not sure how yours taught it to you, but it looks to me like maybe your teacher taught it by like doing what I just showed you here,
right,
by logically putting a couple points on there and making sure it works. One other thing you can do is put another point in, like 0. Put in 0 for x and see what you get. When I plug in 0 for x, what should I get when I plug in 0? I should get something negative probably, or at least I should get,
when you plug in 0 for,
when I plug in 0 for x to my equation, what should I get?
How do you get? Oh wait, no. You can. Lower the tables and.
I should get something negative or around 0, right? Could be positive even depending on the graph how steep it is. But when I plug it in, see what happens. I get the square root of 0 plus 4, which is 4, minus 3, which is 2 minus 3, which is -1. And sure enough, that's the point there.
I gotta conjugate for this one.
Okay.
Does that work for squares?